Hello.
Hello. All right, so this is the database office hours call. Gonna start right off today. I put a topic on the agenda about the thin cloning that we're doing on using Postgres AI and Database Lab. And I wanted to give a quick demo of how that looks like with psql, and we can talk about how we plan to use that going forward. Don't think there is any other topics on the agenda. Feel free to add if there are more. Has anybody, like, I think everybody's using Postgres AI right now, right? Has anybody used psql access to a thin clone already? Right, so basically you can use Postgres AI Database Lab. You go to the UI, you log in, you use Database Lab, you can run queries, you can get query plans, and that's all great. It also works with Slack in a similar way. But a very nice way of using that is also creating a thin clone and then being able to access that using a psql client. So basically, the same way you can log into a production replica today, you would use psql, log into that. You can explore the data there, but you're directly connected to a production replica, which means it's part of the production cluster. You don't want to mess with that too much, and then it's also read-only, so you can't even create temporary tables or tables for that matter, or any indexes. You can't mess with the data. You can't change anything, and that is sort of a limitation. And with thin clones, what you can do is actually grab a thin clone, make that your own, and then you have a fully read-write database cluster. You can use psql to access that, and then you can create indexes, you can change data, you can export data any way you want, and then you start over, you create another thin clone, and you can start fresh, and that's all within seconds. So that's a nice way of kind of using that. Would it make sense to run through a quick example of how that looks like? Cool. This isn't very well documented yet, so this is something that we will still have to do. Otherwise, I would just point to the documentation. For this, I'm just going to share my screen. Just a second. Can you see my console? All right, cool. So basically, we have one GCP instance currently that runs Database Lab. This is, it's not exposing anything on the public network except for SSH. So what we have to do is a bit of SSH port forwarding to get there. And there's basically two things that we want to do. One is talk to the API. So it has a nice command line tool that you can use, has a nice API that you can use to create thin clones. And in order to do that, we still have to expose the API somewhere because it's not on the public network. So what I do here, and this is what you can do when you're set up with your SSH key and all that. I basically just forward the API port to my local machine. So basically, I have this available on a port on my local host. This is the instance that we're connecting to. Yes.
Sorry for interrupting you. Could you please magnify a bit? It's only me, which I'm seeing a very small. Your screen is so.
How about now?
Better, thank you.
Better. All right. Thanks for noting. All right. So this is just the SSH port forward for the API. This is the one instance that we're talking to. And then it's really as easy as using the DBLab CLI tool. You can do DBLab clone create, and then you can basically specify the Postgres username and password that you want to use. So this is the Postgres account that's going to be created for you to connect later. And that's basically it. So this is, what you're not seeing here, that there is a token that you have to configure, but that is basically all that you need to do to create a clone. And this is the time it takes, so about 10 seconds, and you have this thin clone available. What you're getting back there is the connection information. So basically now on the database lab instance, we have a full Postgres cluster running on this port. And in order to connect that, we can use those user and password combination we specified before, this super secure password. And we have to remember the port here because this is what we have to forward. Again, it's only from the database lab instance, it's only exposed locally. So you can't connect to it from the outside. For that, we use SSH again. And this time we basically need to make sure that we forward the right port. So this is the same port, 6010. I forward that to my local port and using the same instance again. And then what I can do is just use my psql client, whatever you like to, or any UI tool. You can connect to that local port. And you're connected to a full read-write thin clone of the production database. Sorry. You can see that here. This is the actual copy of the production database, 9 terabyte in size. It's been renamed, so GitLab HQ production is the actual production database name. And upon thin cloning, it's being renamed because you want to have some indication that you're not working on a production instance. Otherwise, it's very easy to mess up and drop tables in the wrong console, I guess. So that's kind of help in that regard. Right, and then what you can do anything you want with that instance. This is fully your own. I can create indexes. I can drop tables, update data, everything, and then I can just recycle that, create another thin clone, and start over basically. You have any questions so far? Right, I want.
This requires to have an SSH key deployed on the restore instance, right?
On the database lab instance, which lives inside the GitLab restore project currently, yes.
So that would be a request to you or to an access request, or how do we handle this?
This is a good question. This is something we are figuring out currently. I think it's an access request. I don't know yet about the routing, who takes that. Currently, this is the SSH.
I guess because it's production data, I guess it needs to go through the usual path I mean, we need to make sure that only people who are allowed to get production data access, right, get this access. So I guess it needs to be the standard access request then. Yeah.
Yes, I think so too. For the SSH key setup, for Postgres AI, anybody can basically start using that with a GitLab.com email address. You can log into the product on the site and you can start using that. But then you can only access the UI. You can only use Database Lab, where you get the query plans and all that. But you don't have a way of accessing the data directly, like we just saw on that demo, right? So yeah, for that you want to have an access request for sure.
Okay, makes sense.
Cool. All right, and then just to show a quick use case, what we just had this week, there was a request for changing a bit of data in the database, and basically we're using Database Lab and Thin Clone to prepare that, because what you can do is you can create some tables, right? This is something you can't do on a replica. And then what we basically have on the local machine, I have a CSV file there with some data in it that I want to import, and I can just go in and use copy for that, which basically allows me to copy CSV file into that table. And that goes from my local machine to the process cluster. I can now work with that, right? And then you can do all sorts of things. We ended up running a bunch of queries and then exporting data again using copy. It goes in the same way. You can copy from the cluster to your local machine, exporting CSV, and that's really useful for preparing those changes. But you can also, I use it basically on a daily basis to, whenever I want to interact with the database. I don't connect anymore to the production replica. Most of the time I just grab a thin clone and I work with that because I'm totally sure that I'm not going to mess anything up there, and I can just read write data in any way. Cool. And then basically the only thing left is the lifetime of that clone. If you're not using it anymore, then it's going to be recycled and destroyed after a couple of hours, I think. There is a setting where you can prevent that from happening, much like the termination protection in GCP. Other than that, it's going to destroy itself after a while, or you can go in and remember that ID. So this is the clone ID, and you can do that yourself. So basically, you would use database labs again, and you get the typing right and the pasting, and you just destroyed it again, right?
I think I recall when this was first being discussed as a possibility, because with every time you make a clone, it's taking up more and more space. Is there still any concerns about that type of limit if there's a lot of people making these clones?
Yes, this is still a concern. The disk space is obviously not unlimited, and the longer you leave a clone around, the more space it's taking, roughly. And obviously, when you're making changes to the clone, then this is also taking more space. But it's not that an additional clone is a full copy of the data. So this is incremental in a sense. And at the moment, I wouldn't bother being concerned about that. If we run into those limitations, then yeah, we need to do something about that. Add more disk space.
Okay.
Same goes for that termination protection. When you enable that and you forget about that, then we'll have some kind of this event at some point. And then the usual caveats apply as well. Just like with Database Lab, this is not a production instance, so it has a couple of differences in terms of instance type. It's much smaller, and then it's also based on ZFS for those reasons, for thin cloning. So that gives you a bit different characteristics. So the performance can be much different compared to production. There is an interesting work going on where Nikolai is proposing to implement an estimator. So based on the performance that we see on Database Lab, what do you expect to see in production? And we would be able to estimate that for timing numbers, for example. But that is sort of still ongoing work right now.
And this is very nice. I wanted to ask if this is going to be more recommended instead of having access to a replica. So currently I have access to replica, and I was actually not using it lately, maybe in a couple of weeks, but would be maybe recommended to use this instead?
I think you can do both. I can only tell from my usage of this. I've grown very used to just creating a thin clone and working with that. You're more flexible with what you can do. You're not at risk at running gigantic queries and breaking the production replica. On the flip side, it sometimes takes longer. So some queries are just very slow compared to production replica. But if you can manage that personally, I use the thin clones very often.
And you also don't have the statement timeouts that you have in a replica if you want to do some explorative analysis.
Exactly. And for analytical queries, like in the situation when you don't expect to change anything, so you don't really need a writable cluster, there is always the option to also use the archive replica for that, where we don't have those statement timeouts either. Most of the time I would expect this to be faster than working with database labs for those queries. But whenever you need that flexibility of being able to change things, database lab is the only option that you have, basically. Yeah, and sort of going forward, what we would love to do, what is sort of a very natural thing to do with those thin clones, and we've talked about that before, haven't we, about connecting your development environment to that, running migrations on the thin clone. And this is something that we're driving forward right now. It is not recommended to connect your development environment to it still. Probably not going to happen that we recommend that because of the security concerns associated with that. But what we are going to have is a environment where these, for example, database migrations are being kicked off automatically, and this is sort of lockdown CI environment that runs automatically, runs those migrations for you, and you get some feedback on the MR. So this is what we're currently working on to get going. There's a very minimal product out there. I linked an example with the feedback that you would be getting back. So the workflow is basically you push a change with a migration, that kicks off CI, which basically kicks off another pipeline in a locked down environment that runs the migrations for you, grabs a thin clone like we just did, runs the migrations, and gets some statistics. Right now it's just runtime, so it reports only back the runtime for those migrations. But we have a lot of discussions going on where we can add. You can do query statistics. You can do log observations. So what kind of logs does this migration take? Are those dangerous or not, and stuff like that. And all that will be reported back on the MR. So you get a comment with all those details. And for database maintainers, you also have the ability to look at the locked down pipeline. So you will be able to see those, basically the output of the migration that are being executed, in case there are any errors or any log statements that you want to look at. So that's hopefully useful.
Andreas, maybe it will be interesting to others if you walk through the diagram that we have in the GitLab database testing and discuss. This is super technical, but at least I find it interesting if other people find it interesting on how this is going to work.
Sure.
Because, yeah, the plan there is that we're going to test all migrations for all MRs. So this is huge. And what Andreas just presented will be automatic in all CI pipelines. So, yeah. And so if Andreas wants to.
Sure. Yeah, I can try that. Those pictures are not so sophisticated. Take them with a grain of salt. Can you see my browser? All right. I hope you can read it. I probably increasing that a little bit. So okay. So this is on the database team group. There's this GitLab com database testing project. We have just renamed that from migration testing to database testing because migrations is a huge thing that we can do, but we can also do more. So we can also we think also about automatically getting query plans for your changes, basically. So this is more than just migration testing, at least the idea. We can see how we get there. There is a bit of README, but the basic problem that we're solving, I mean, taking migrations and running them on the thin clone is not very difficult, right? I mean, we've just seen how we create that thin clone. You can connect to that using psql. And of course, you can also configure your GDK environment or GitLab environment to run those migrations on that. So that's not super difficult to do. What is sort of most concerning in that context is the security aspect and the fact that we're working with the full copy of the production database. This is considered red data. So the most important data for us, the one that we have to protect the most. And as such, what we can't do is sort of add a job to our regular CI pipeline that just runs, grabs a thin clone and just executes the migrations and on top of that data. The reason why we can't do that is you would basically be able to send any kind of code, any type of migration, but also any kind of malicious code if you become creative about that. And you would be able to inject that into an environment where you run that on the production data and be able to observe the output of that. And potentially also, I don't know, copy that data somewhere. So there is no limitation with regards to network isolation and those kind of things. So we can't have it in that open way, and that's why we need a more locked down project. And what we're basically working on right now is having a separate project. This is what you can see here. This is being mirrored to the ops instance. We have the ops.gitlab net instance, which is a private instance that we run. And that has a mirror of that project where those pipelines execute. And basically only in the future, only database maintainers would have access to that project and the pipelines and the output of all that. And in order to run the pipeline on that project, we have two runners. One is called the builder, the other one the worker. And basically the idea is, and I don't know if that translates very well with that picture, but basically the idea is that we have this builder. It's a standard shell executor that is building Docker images for you. So doesn't do anything else. It doesn't run any code. It just builds Docker images. It pushes those Docker images to the registry that lives on the other runner. And basically the worker runner executes from that registry, and it doesn't have any other network connectivity. So it can't connect to the outside world really, except for its own local registry. So it's basically similar to the idea of how do you assign SSL keys, where you can't have any network connectivity. You build something on a regular network, and then you inject that into a locked down environment where you do the signing and the running and the more security related stuff. And this is the environment that you control more. This is what we're doing here as well. Internally, this is spinning up a couple of services. So one is Redis, this is standard Redis. We need that to run the migrations. The other one that we would need is a Postgres instance. So in CI, you would see a Postgres instance instead of this one. What we do here is we basically run a service that performs the same steps as we just saw in the demo. So SSH port forwarding to the API, using the DBLab CLI to create a thin clone, and then port forwarding that. So it's sort of, it looks like a Postgres from the outside. It exports the Postgres port, but in fact, it just forwards to the database lab instance. And this is the only hole that sort of is in the network here. Other than that, this container basically runs GitLab Rails, and also in a way where you, on top of all the isolation that we already have, so on top of limiting the network for this runner, we also have IP tables going on in this container. So there is no network connectivity except for the local Docker network talking to those services. And this is actually where the migrations execute. So this can't talk to anything else than the Postgres and the Redis, and that's it. It executes the migrations, and it basically produces an artifact, which is a JSON file with all the statistics. Right now, it's just the information that which migrations ran and how long that took, basically. But we would drop all those query statistics and everything else we want to report on. We would drop that into a JSON file as an artifact. And then there is a final job going on that sort of picks up that JSON file that runs on this builder runner again, because this is the one that can communicate to the outside world. It can also communicate back to the GitLab com merge request. So we're using the JSON file and we push a comment or whatever makes sense to the original merge request with those those statistics and reports that you can see here. Yeah, that's what we currently have is the runtime and the migration. This can be much more. Yeah, I think that's basically the idea, sort of, and yeah, the biggest concern is really the security side. How do we make sure that nothing escapes and we can't run sort of, well, we have some controls over what kind of code runs on production data and who can sort of see the output of that code, basically. Any thoughts about that?
Yeah, this is great. I think this is going to be used a lot, and looks really, really nice. I think, yeah, thanks for working on this, everyone.
Cool. Yeah, really excited about that as well. I think it's a major step for us to run this automatically and get the feedback. I hope this is going to be useful.
Totally. I think that it's going to be very, very useful. I'm looking forward to see this output in MRs and try to understand more about how the code that we write is affecting or touching database.
Mm-hmm. And we just added that, or we're just about to merge that. I think that this is being triggered already. So even though, so there's going to be a job on the regular CI pipeline soon that's triggering those testing pipelines. It's probably not going to be available for all the MRs, so we're still, early phase testing that. But what I've already seen is that this is also very fast in terms of how fast do you get feedback from that. The job kicks off very quickly, so pretty much in the beginning of the regular pipeline, we trigger the other pipeline, and given that most of the things are being cached, so the Docker cache is pretty good, there's not much we need to do on that end. The thin cloning is very fast as well. It takes like 10 seconds to get that clone. You can expect to get feedback from the migration maybe a couple of minutes after it started, plus the execution time for the migration, obviously. That's kind of nice, getting that so quickly. If there is something that you want to see from that testing kind of statistics, or what metrics can we add, I'm sure there is a lot that we can do that will be useful. We have an epic on our tracker, which I don't have handy right now, but I'll put that to the agenda in a moment. If you have ideas about that, be awesome to hear them. I'll leave a comment on the epic or create an issue. That'd be awesome. Oh yeah, and in addition to that, there is the blueprint for database testing. I also linked that on the agenda. That is basically a summary of what we just talked about. If you want to leave feedback for that, it's also much appreciated. Thanks, Yanis. Right, so much for the database testing. Do we have other topics or other thoughts today? You have a nice shirt, Steve. But I can also only see half of the tanuki. Is it the standard GitLab shirt? Right.
Yeah,
nice.
the standard one.
We just got some swag as well. It's a bit hard to put on. How do you like
cool.
these?
Nice.
We have a logo now.
Yeah. You can see it on the issue tracker as well. Cool. If we don't have more topics, you all have a good day. It was nice seeing you.
Thanks a lot
Talk
for
to you soon.
presentation. Have a good
Sure.
day.
You too. Bye-bye.